Good afternoon, class. We are looking at practice test number 5, module number 5, covering chapters 10 and 11, chapter 10, analytic geometry, chapter 11, sequences and series. And again, the pledge that when we take the exam on our own. So the first part is about analytic geometry. Find an equation of a circle with its center at 1, -2 and radius 2. Graph the circle. Reminding you that the circle has the following definition. A circle is the set of points in a plane that are the same distance, called the radius, from a fixed point called the center. If it's centered at 0, 0, with the radius r, x squared plus y squared equals r squared, and the proof is very simple. Just follow Pythagorean theorem. If it's centered at h, comma k with the radius r, again, Pythagorean theorem says x minus h quantity squared plus y minus k quantity squared equals r squared. So in this case, all right, so we are dealing with a circle, as mentioned, with the following formulas: x squared plus y squared equals r squared, x minus h quantity squared plus y minus k quantity squared equals r squared. We should know the area is pi r squared and circumference is 2 pi r. In this case, the radius is 2. The center is at 1 minus 2. So according to this formula, we get x minus 1 quantity squared plus y minus minus 2. That means plus 2 quantity squared. R is 2. Therefore, 2 squared is 4. Now, it's a good practice to put the center 1 to the right, 2 down. And then we go r units, 2 units to the right and to the left of that, r units, 2 units up and down. So 2 units left and right. So if you look at this and you want to move to the left, 1 by 2 units. 1 minus 2 becomes -1, and to the right, 1 plus 2 becomes 3. So we have -1, -2, 3, -2. Going back to the center, we want to go up and down by 2 units. So if you want to go up and down by 2 units, then the y coordinate, you go up by 2 units becomes 0, down becomes -4. And you connect. And there you have it. Write the equation of a circle in standard form. Identify the center and the radius and graph the circle. So what do we have to do? It's very simple. We are going to put the x squared and minus 4x together, y squared and 10y together, and move the -7 to the right, make it positive. That's the first step. We're going to complete the square in each case. This one, b is -4. This is b. I'm going to divide it by 2. I get -2. I square it. I get +4. In this case, b is 10. Divided by 2 is 5. Square it is 25. So we are going to add 4 and 25. And of course, 4 and 25 to both sides. The left side, this is x minus 2 quantity squared. This is y plus 5 quantity squared. And the result is 36. So the center is located at +2, -5. The radius is square root of 36, which makes it 6. So you come up with the center at 2 to the right, 5 units down. This is 0 to 5. This is 0 to negative 5. So 2 is here with negative 5. And now we are going to go R units, 6 units to the right and left. So look at the x coordinates. To the right, 2 and 6 is 8. To the left, 2 minus 6 is minus 4, the same y coordinate. And going up and down by 6 units, add 6 to minus 5 and subtract from it. And we get those points and we connect them. Graph the ellipse by defining its center and vertices, x squared over 25 plus y squared over 16 equals 1. So what is an ellipse? Is the shape of an ellipse. Ellipse is a circle that is elongated on one side, either along the x or y axis. This one is centered at 0, 0. The intercepts are a comma 0 minus a comma 0. The y-intercept are 0, b, 0 minus b. These are focal points or foci, focus 1, focus 2, c0 minus c0, and a point P has coordinates x, y, and here's the definition. An ellipse is a set of points in a plane. The sum of whose distances from two fixed points is a constant. So from here to these two fixed points. The two fixed points are called the foci. Each is a focus of the ellipse. F1 and F2 represent the two foci of an ellipse. So PF1 plus PF2 is fixed, and it's equal to 2A, because if you look at this point A, AF1 and AF2, by symmetry, this distance, everybody, this distance, AF2, and this distance, you can call this BF1, they are the same. Therefore, from here to here, if we want to add this much, is the same as adding this much, and becomes from here to here, from minus a to a, it's 2a. That's, believe it or not, that's the proof. Now, what it means is that if you pick any point, that works out. And because of the symmetry again, and this distance is the same as this distance, this one is in common, these two distances are the same as well, which gives rise to the question that if this distance is C and this distance we're going to call it B, then this distance is equal to A, because A squared plus B squared is equal to C squared. In this case, A, it is elongated along the x-axis, A is larger. Okay, so take a look at this one. So this is B, this distance is B by definition. So is this distance C by definition. A can be calculated. This distance from here to here can be calculated using Pythagorean theorem. So we're going to write x squared over a squared plus y squared over b squared equals 1 if it's centered at 0, 0. If it has a different center such as h and k, x minus h quantity squared over a squared plus y minus k quantity squared over b squared equals 1. Now, what I want to explain here, before that, I want you to note that a circle is a special case of an ellipse where A is equal to B equals R. If A and B are identical, it becomes a circle. And so, because the area of a circle is pi r squared, this is pi AB. And again, b squared plus c squared is a squared by the Pythagorean theorem. If you erase my work and do this one, if you look at this triangle. So this distance is A, This distance is B. The focal distance from the center to focus 1 and focus 2 are identical, and it is C. It may not be to scale, but you get the picture. One easy way to see this is if you look at this point, and let's call this point capital B. I hope you see that BF1 plus BF2 by definition of an ellipse is also 2A, right? So that becomes A. I'm going to erase my. The center is located at 0, 0, everybody. You are comparing it to this one. And A is square root of 25, which is 5. B is square root of 16, which is 4. So the vertices, where it's the side that is elongated is considered the vertices. For example, in this case is A0 minus A0. So that would be 5, 0, and minus 5, 0. If it's elongated along the y-axis, then B, 0, B, and 0 minus B would be the vertices. So the vertices are 5, 0, minus 5, 0. The other part is called co-vertices, 0, minus 4, 0, 4. So this is the center. 5, 0, minus 5, 0. Those are the vertices. 0, minus 4, 0, 4 are co-vertices, the terminology. And it looks like that. Of course, because 5 and 4 are close, it looks similar to a circle, but like I said, it is an ellipse. We're going to move on. Identify the coordinates of the center, the vertices, co-vertices, and foci. Graph the ellipse. X plus 5 quantity squared over 4 plus y minus 7 quantity squared over 9 equals 1. All right. So we compare it to this, and quickly we recognize the center is located at minus 5 plus 7. A is square root of 4 or 2. B is square root of 9 or 3. Okay, comparing it to that. So we start with the center. 5 units to the left, 7 units up. This is -4, -6. So 5 units to the left here. 6 and 8, 7 is in between. And now let's discuss the vertices. Because B is larger, so the vertices are along the y-axis. So you are going to add and subtract this number from the center. So here's the center. We're going to go up, becomes minus 5, 10 by B units, We're going to go down by B units. 7 minus 3 is 4, so minus 5, comma 4. So those are B units up and down. I say B in general. In this case, B is 3, everybody. In this case, B is 3. And again, because B is larger than A, the vertices are along the y-axis, okay? Now, we go back to the center, and we're going to go A units to the left and right. So A is 2. If I want to go to the right, I'm going to add 2, becomes minus 3. If I want to go to the left side, I subtract, and it becomes minus 7. So minus 7, 7, minus 3, 7. You plot those, you connect it. There you have it. Again, it's elongated along the y-axis because B was larger. So that's why they are called co-vertices. Now, it's important to know B squared plus C squared equals A squared. We use Pythagorean theorem, and this side is the one that is larger. Okay. Now, in this case, because B is larger, okay, it's either A squared plus C squared equals B squared, or B squared plus C squared equals A squared. And obviously, since B is larger, we are going to go with this one, everybody. So 2 squared plus C squared equals 3 squared. This is 4. This is 9. So C squared is 5. C is square root of 5. And so we go back to the center. And again, it's along the vertices as far as the location of foci is concerned. So from the center, you go up by C units and you go down by C units. So that means -5, 7 plus minus square root of 5. So when we subtract square root of 5, we get about 4.77. And then when we add, we get 9.24. And those are the 2 points roughly. Use the graph of the ellipse to determine its equation in standard form. So this is the information. And because the center is not located at 0, 0, we're going to start with that first. X minus h quantity squared over a squared plus y minus k quantity squared over b squared equals 1. First, we notice the center is located at negative 2, 2. Then we put the 4 main points. These are the vertices. These are the co-vertices. This one, -2, 5. This one, -2, -1. Co-vertices. This one, -4, 2. This one, 0, 2. So we have this distance and this distance as A and B. This one is A, which is 2. This one is B, which is 3. Again, just look at this coordinate, y coordinate 2, and this y coordinate 5. The difference 5 minus 2, okay? Whereas this one, you can say the difference of these two or difference of these two along the x-axis. So what do you have? If A is 2, you put 4 here. If B is 3, you put 9 here. H and K, X minus H, X minus minus 2, that means plus 2. Quantity squared, Y minus K, Y minus 2. Quantity squared over 9 equals 1. Very straightforward, everybody. A quick recap, you just locate the center and these 4 points, vertices and co-vertices. The distance between these two is 8, the distance between these two is B. Give the equation of the asymptotes and graph the hyperbolas. The first one is x squared over 16 minus y squared over 25 equals 1. The second one is y squared over 25 minus x squared over 16 equals 1. So first, let's remind everybody of what is a hyperbola to begin with. Here's the definition. A hyperbola is a set of points in a plane, the difference of whose distances from two fixed points called the foci is a constant. If you pick a point P and you connect it to the further focus F1, minus connected to the closer one, PF2. This is equal to 2A. And the proof is, again, if you go with this point A, AF1, if this works for every point, it works for this vertex as well. AF1 minus AF2 equals this distance. And if this distance is A, because this is located at A0, everybody, then this is 2A. That's actually easy to see. Now, the equations are as follows. X squared over A squared minus Y squared over B squared equals 1, or Y squared over B squared minus X squared over A squared equals 1. I want to explain something about here. And in most texts, they interchange A and B depending upon which one has a positive value. Because this has a positive value, this is fine, but this one, they put the A squared here. I don't, and the reason I don't, if you don't change it, the asymptotes in both cases remains the same, plus minus B over A times X, A squared plus B squared equals to C squared, okay? And I'm going to explain the difference between the two. As far in general, when you have a positive value for X squared over A squared, that means it opens sideways. If it's Y squared over B squared first, then it opens up and down. But everything else is identical. By that, I mean how you come up with the graph and the equation of asymptotes, okay? It makes no difference. And again, this distance is A, this distance is B, and the relationship is A squared plus B squared equals C squared. The focal distance, by the way, let me just show you this value of C is from here to this one. So this distance is C, the focal distance, everybody. All right, so in both cases, what's in common? The center is at 0, 0. A is 4, B is 5. So the center is the same for both of them. And for both of them, because this one is here, okay, everybody? The asymptote is plus minus B over A, plus minus 5 over 4x, which means you have two lines that go through the origin. And we have what is called the fundamental rectangle. Fundamental rectangle, if you see what color I want here, I'm going to go with this color. If you look at this one, A is 4, B is 5. And if you locate 4, 5, negative 5, negative 4, 5, negative 4, negative 5. And if you connect those points, that means these 2 points and these 2 points, those are the diagonal of the fundamental rectangle. And those diagonals are the asymptotes. So one easy way to graph asymptotes is to just the moment you have A and B, put 4, 5, and then various points, make one of them negative and eventually both of them negative, and we have it. Now, for the blue one, the vertices are at 4, that A0 and minus A0. That means 4, 0, minus 4, 0, because this one opens sideways. So these are the ones, that's the graph, you're done. For this guy, the vertices, this uses everything the same as this one, except this opens up and down. So we have the vertices at B is 5, 0, 5, 0, negative 5, and it opens up and down. That's the difference between the two. So a quick recap, everybody. A is x squared over 16 minus y squared over 25 equals 1. B is y squared over 25 minus x squared over 16 equals 1. Both of them are hyperbolas, and they have the same center, the same value for A and B, the same equation for asymptotes. The difference is this one, because x squared over 16 has a positive value, then the vertices are along the x-axis, and therefore it opens sideways. But this one, because y squared over 25 has a positive value, the vertices are on the y-axis at 0, 5, and 0, negative 5, and it opens up and down. So that's important to understand. Identify the coordinates of the center, the vertices, foci, and the equation of the asymptotes. Graph the hyperbola x minus 1 quantity squared over 9 minus y minus 2 quantity squared over 16 equals 1. And so here's the equations. And a squared plus b squared equals c squared does not change because c is always larger than both of them. It's unlike an ellipse that changes from one format to the next. So having said that, we are going to start with the center. The center is located at 1, 2. A is square root of 9 or 3. B is square root of 16 or 4. So that's the first thing that we want to write. So the center is located at 1 to the right, 2 up. Now to find the asymptotes, remember the asymptotes have the equation y equals plus minus b over a times x when the center is at 0, 0. When the center is at h and k, see what happens. Instead of y, you would have y minus k. Instead of x, you would have x minus h. In other words, I'm going to remind you, we had the formula y equals plus minus b over a times x, right? Now, this says change it to y minus k. This says change it to x minus h, and that's exactly what we get here. So this is h, this is k. So this is y minus 2. This is x minus 1. B is 4. A is 3. So I can put the negative 2 to the right, becomes positive 2. And then if I go with the positive one, let me just write it here. If I go with positive, because I have to calculate the negative also. So let's calculate the, okay, let's do it this way. Calculate the positive first. 4/3 times x minus 4/3 plus 2. Okay, that's one of them. And these 2 is 6/3. We get 4/3 x plus 2/3. Clearly, this gives you 0, 2/3. And if you set y equal to 0, that means x must be negative 1/2. I'm assuming no one has any problem getting the x and y intercept. So you locate these 2 points, you draw the line, and this is your asymptote. I'm assuming no one has any problem drawing a line. Now the second one, let me use a different color. Y is minus 4/3 x. Minus times minus plus 4/3, and then plus 2 6/3, they add up to 10/3. Which means I have 0 10/3 as the y-intercept. And if I set y equal to 0 minus 4x becomes 10, it becomes 5 halves, 5 halves 0. And again, use these two pairs, draw the other asymptote, and I'm going to erase my word because I need the room. Now, we go back to the equation. We notice this has a positive value, therefore it opens sideways. So all you have to do, find the value of A. We already have it. So it's going to go 3 units, A units to the right and left of the center. So from the center, go A units to the sides. So I'm going to come back to the center. And if I want to go to the right, by 3 units, this becomes 1 plus 3, 4. So 4, 2. If I want to go to the left, 1 minus 3 becomes negative 2, 2. So negative 2, 2, 2, 3, 4, 2. I'm going to connect them in the following manner. These are the asymptotes. It continues indefinitely. So that's the graph, and I'm done. What I want to find is to find the value of C and therefore the foci, and I'm going to use the fact that A squared plus B squared equals C squared. So 3 squared plus 4 squared is C squared. This is 9. This is 16. We get 25, and C becomes 5. Again, reminding you the center has coordinates 1, 2. We already know that. So we are going to go C units to the right, to the left. Okay. And so if I want to go to the right, 1 becomes 5, 6, comma 2. If I want to go to the left, 1 minus 5 becomes negative 4, comma 2. So C equals 5. Units to the right and left. Here's the foci. We are done, and this is the fundamental rectangle. Let me just write that. So this is called fundamental rectangle. Now, use the graph of the hyperbola to determine its equation in standard form. Let's see what we have. The center is located at minus 1, 0. So that's the center, located at minus 1, 0. It opens up and down. That means the vertices are at negative 1, 3, negative 1, negative 3. That's given. So that means this distance must be B. Therefore, we are looking at them being located B units up and down from the center. So they have the same X coordinates. The Y coordinates, the difference is 3 from here to here or from here to here, which indicates B. This distance must be 3. The foci, negative 1, 3 square root of 2, and negative 1, negative is 3 square root of 2. There are two of them. And they are located C units up and down, therefore, from the center. Therefore, if this distance is a C, that means this distance is 3 square root of 2. Or you can look at this one. So the foci is located at negative 1, 3 square root of 2, and negative 3 square root of 2. And we are looking at this distance to be 3 square root of 2. Why is this important? Because a squared plus b squared equals c squared. So let's plug in a squared plus b squared, which is 3 squared, equals c 3 squared of 2 squared. So as you know, this is a squared, this is 9, 3 is 9, square root of 2, 2, 2 times 9 is 18. And that subtracted from 18, a squared becomes 9, and a becomes 3. So we are going to write x minus h quantity squared over a squared minus y minus k quantity squared over b squared if it opened sideways. But we're going to use the second one because it opens up and down. So we're going to use y minus k quantity squared over b squared minus x minus h quantity squared over a squared equals 1. This is the one we're going to use. We go back to the center. The y coordinate is 0, so y minus 0 is simply y. The x is minus 1, so this is x minus minus 1 or x plus 1. B and a are both 3, so both of them are 9. Y squared over 9 minus x plus 1 quantity squared over 9 equals 1. So we are going to go with y minus k. That means just y, or y minus 0, equals plus minus b over a. That means 3 over 3x minus h. That means x plus 1. And so this has no bearing, simply 3 over 3 is 1. Y is plus minus x plus 1. That means x plus 1 and minus x minus 1. I want to make sure we understand this is representing two lines, x plus 1 and minus x minus 1, which means they're following asymptotes, everybody, which means they're following fundamental rectangle.